Okay, we are going to learn about fractional equations today. This is lesson 7.4. And an equation with a variable in the denominator of one or more terms is called a fractional equation. So if we look at this equation here, I have two fractions. This fraction in the denominator is a variable x. This makes it a fractional equation. Okay, and there's two ways we can solve these. One of them is to solve a fractional equation. You can multiply both sides of the equation by the LCD. Now, we've done this before when we've had fractions that were the coefficients were fractions. And so we've multiplied the entire equation by the LCD to get rid of those fractions. It's the same method that we're going to use for this one. Another way to do it is to use cross products. And you can use cross products when you have a fraction equal to another fraction. So a problem like this, we could use cross products. If I had something where I had another fraction out here, so I had 4/9 plus or minus something, I would have to use the LCD. So let's start by looking at the LCD. So if I look at these two fractions, my LCD is going to be 9 times 3 minus x. Okay, so what I do is I put the whole thing in brackets or parentheses, whatever you choose, and I'm going to multiply by 9 times 3 minus x, not x minus 3. 3 minus x, okay, over 1. Now, because I'm multiplying both sides of this, it's fine, okay? So just remember, you got to multiply both sides. So when I multiply here, I have 3 minus x and 3 minus x, so they're going to cancel out, and I'm left with 9 times 2 minus x on this side. When I look at this side, the 9s will cancel out, and I'm left with 4 times 3 minus x. So now I have just a regular equation that I can solve. I'm going to distribute. So I have 18 minus 9x equals 12 minus 4x. I'm going to add 4x to both sides, and I'm going to subtract 18 from both sides. Okay, so I end up with negative 5x is equal to negative 6. So x is equal to 6/5. Okay, that's using the LCD. I could also solve this using cross products because it's two fractions that are equal to each other. Make sure you put your binomials or trinomials, sometimes you have trinomials, in parentheses because you're going to have to distribute. So if I have the first one, I have 9 times 2 minus x equals 4 times 3 minus x. And if I look, that's exactly the same thing. The only difference was I didn't have to figure out what the LCD was. Here I did, okay? So that was kind of like an extra step. But then I'm going to go through and it's obviously going to give me the same answer. And I end up with negative 5x equals negative 6 and x is equal to 6/5, okay? So this one obviously is easier, but you can only do it when you have a fraction equal to a fraction, okay? So when you have a proportion is the only time you can use cross products. Okay, so here's some more definitions. These are for units of measurement. A rate is a ratio that compares the amounts of two different kinds of measurement. Okay, so a rate might be something like miles per hour. Okay, those are two different types of measurement. This measures length, this measures time. I could have dollars per gallon. Okay, again, two different types of measurement. So that's a rate. A unit price or a unit rate is the price or unit of one of one. That's because unit means one. So it might be something like 10 miles for 1 hour or $12 for 1 pound. Okay, so this is a unit price. This is a unit rate. A unit price is a unit rate. It's just specifically money. Okay, we can also use something called dimensional analysis to change units. So here I have 40,200 kilometers per hour, and I want to know how many meters per second that is. So let me show you how we set that up. First of all, you're going to write it as a fraction. And I'm going to keep my units in there initially so that I can cancel them out. So basically, you're going to pretend like, this is like fantasy, pretend like your units are variables, okay, even though they're not. If I wanted to get rid of this h, if I put it up here, these two would cancel out. So I want to get rid of the hours and change it to seconds, okay? So if I put the hours up top here and I treat them like variables, these would cancel out. Well, then all I need to know is 1 hour is how many seconds? Well, it's 3,600 seconds because there's 60 seconds in a minute and 60 minutes in an hour. Okay, so now I've gotten, instead of hours, I'm going to have per second. So my seconds are in the bottom. I also want to get rid of the kilometers, and since kilometers are in the top, I can put them in the bottom down here, and those will cancel out. And what I'm looking for is meters. So now all I have to do is say, well, what's the relationship between meters and kilometers? Well, 1,000 meters is equal to 1 kilometer. Okay, so now my units, I cancel out the units, and I'm going to end up with meters in the top and seconds in the bottom. Okay, so now all I have to do is the numbers. Well, here I have 3,600 and 1,000, so I can divide both of those by 1,000. That gives me 36. And I basically have 40,000. I'm going to write it like this. 40,200 is in the top and 36 is in the bottom. And I can simplify that. So 40,200 divided by 36 is a lovely number, 111, 6.6 repeating. And we're going to change that to 2/3 because we want to. So 1,116 and 2/3 meters per second. Okay, so that's called dimensional analysis. And basically it's changing units. So if I have a rate or a unit rate or unit price, I can change the units basically by treating the units as if they were variables and this canceling them out. Okay, so let's look at the try this. Okay, so here we have an equation. It's a fractional equation, but it is not a proportion. So in order to solve this, I'm going to have to find the LCD. So the LCD, 2 goes into 10, so it's going to be 10t. That's my LCD, 10t. So I'm going to multiply my entire equation by 10t over 1. So I have 3 over t minus 1/2 equals 1/10. And here when I multiply, the t's will cancel out, and I'm left with 30. And here, 10 divided by 2 is 5, so I have 5t. And the 10s will cancel out, and so I'm left with t there. That's going to give me 30 is equal to 6t, and t is equal to 5. Okay, if I plug that in, let's just plug it in to check it. So I would have 3/5 minus 1/2 equals 1/10. LCD again is going to be 10, so this would be 6/10 minus 5/10, which equals 1/10, which is correct. Okay, so there's a case where we're using the LCD. This one, at first glance, you say, oh, well, I have to find the LCD for this, but I don't because it's equal to 0. So all I have to do is add 10 over n squared minus 4 to both sides, okay, and it cancels out here, and I'm left with this. And look at that. Now I have a proportion. Okay, so when you have two fractions that you're adding or subtracting and they're equal to 0, you can easily change it into a proportion. And now I can do cross products. So I'm going to have n squared minus 4 times n plus 1 equals 10 times n plus 2. Okay, now there's a couple ways we can think about how we could solve this. This one I can factor n minus 2, n plus 2 times n plus 1 equals 10 times n plus 2. And I could cancel, I could try canceling out the n plus 2's. Or, let's do this. If I divide both sides by n plus 2, okay, those cancel. And I'm left with n minus 1 times n plus 1 equals 10. I can then use FOIL for this. And the reason I'm allowed to do that is because this tells me I'm going to have two solutions. So this is showing me I still got those two solutions in there. So I am allowed to factor out like that. So this will be n squared plus n minus 2n minus 2 equals 10. So n squared minus n minus 12 equals 0. And I can factor that, hopefully. 3 and 4, so negative 3 plus 4. Let's double check. 3 times negative 4 gives me negative 12. 3 plus negative 4 gives me negative 1. So n is equal to 3, negative 3, and 4. And it helps if you can see it. Okay. So this one I changed to a proportion because I had this n squared, it told me I should have two solutions, which tells me at some point I'm going to have to factor, which I did here. Here my highest exponent is just 1, so I'm just going to have the one solution.